In this video, we want to review analysis of variance table, or we call it ANOVA table as well. We want to review ANOVA table and then the application of the ANOVA table in the simple linear regression. We're going to talk about that in more details in chapter 2 when we have like multiple linear regressions as well. But let's look at the ANOVA table. You can see it here. In the previous video, we talked about the fact that sum of a square of the total in the simple linear regression models, it's equal to the sum of a square of the regression plus sum of a square of the error. You can look at it in the previous page. So we would say the breakdown that we have for the of the variability of the sum of a square of the error and sum of a square of the regression, when we add them together, it's gonna give us the sum of a square of the total for the total of our model. When we are looking at this table, you can see that we have the source. We call it source of variation. So the source of the variation here can be regression, our error, and then we are going to add them together. So here for the source of variation of the regression, so we can have for regression we have the sum of the square of the regression. This SS means sum of the squares. It's like that. You can see that. So it's the squares of these ones, like the deviation of the y estimate comes from the regression model, right? Minus like the y bar. And then we add them, so it's the sum of the squares of the regression, sum of the square of the error, and then sum of the square of the total. Then we have the degree of freedom. So for the degree of the freedom of the regression, we would say that it's equal to the number of the parameter in the model, so whatever number of parameters that we have. Like for example, if we are looking for the simple linear regression, the parameters that we have are like A and B, right? We said that A plus BX. Or if you're looking on the second year stats course, you will see that the parameter over there we showed that by beta null and beta 1. It doesn't matter, right? Alpha null and alpha 1, or A and B. Anyway, as long as those are the coefficients that we would have in the model, right? So those parameters in the models, -1 is going to give us the degree of freedom of the regression model. Then for the degree of freedom of the error, we would say it's the number of the observation, whatever data points that we have, minus the P, and the number of the parameters that we will have. It's going to give us the error. And then, so here is 2 again, when we have simple linear regression. And total degree of freedom is the same as before. So we said that the total degree of freedom in the simple cases is going to be n-1. After finding out the sum of the squares and the degree of freedom, we are going to have mean square. So here it's written, what is the MS essentially? It's the mean square of the error. It's like that we would say it gives us the best estimate of something. Like when we have like mean is like an average, right? So we would say mean square of the errors, whatever sum of a square that you have, like mean square of the error or mean square of the regression. So whatever sum of a square that you have, like sum of a square of regression, if you divide it by the degree of freedom, it's going to give you the mean square of that one. So here mean square of the regression is going to be SSR over the degree of freedom of the regression, and then mean square of the error is going to give you SSE divided by n-p. This SSE over n-p, we call it MSE, or in some books they write it down MS, and then like you will see the E is like this. This is in fact your sigma 2 estimate. So it's very important. So the whole table, we call it ANOVA table. So and you can see it here, analysis of variance. One of the outputs of the main output of the ANOVA table is this F value, because this is the F observed or F of the problem, and then we can compare it with the F critical the F that we read it from the table, and we can say that, okay, so if the F observed was greater than the F critical, in that case, we are going to reject the null hypothesis. So that's one of the main applications of the ANOVA table. Another main output of the ANOVA table is this one, this MSE. So SSE over N minus P, it's going to give us the sigma 2 estimate. So you will find out the variance of your model, in fact, the total variance of your model. So it's going to, the other name that we have for this MSE is the sigma 2 estimate. Remember this one. Okay, and then F of the problem, we can, sometimes they write it down F problem, or they would say F of the data that you have, F of the observation. All of these are the same, but you would compare it with the F critical, and I said if it was greater than the F critical, you reject the null hypothesis. Now let's